Okay, this is Unit 4, Lesson 4 of our Pre-Calc 12 class. Unit 4 is called Polynomial Functions. Lesson 4 is called Imaginary and Irrational Zeros. Okay, so what we're going to learn is how to identify, when we're solving for x-intercepts, how to identify when a polynomial doesn't have a root on the graph. Okay, so here's a graph, and here's a polynomial graph and its polynomial function. The graph, we can see, has one root, and the root is at -7. The polynomial, if we solve for x, we can find three unique zeros. Because of the x plus 7, -7 is 0. Because of the x squared plus 1, we get an equation x squared plus 1 equals 0, or x squared equals -1. Square root both sides, we get x equals plus or minus the square root of -1. Don't forget, when you square root both sides, you put plus or minus on the numerical side. And so because of that, we get, and also the square root of -1 is this imaginary number I. And so that's just by our definition. We have a positive I and a negative I. So positive I and negative I are two of our zeros. Now they're imaginary numbers. So on the graph, because I have imaginary number I for each of these zeros, it means it's not a root on the graph. Okay, and so the one quick side note here, because of that, we know that if I multiply this out, this would be a polynomial of degree 3, because our biggest exponent would be when we multiply x by x squared, when we FOIL this thing. So degree is 3. There's 3 potential roots on the graph, or there can be less than 3 roots. In this case, because 2 of the zeros are imaginary, it'd be 3 potential, or the degree of 3 minus the imaginary numbers 1 root. That's just a little shortcut way to think about it. Okay, let's look at some more examples. So here's a polynomial function that's graphed. Here are a, b, c, d are polynomial functions. Which one matches the graph most closely? And so because we have a x-intercept at 8, we know that x minus 8 has to be one of our factors. So for that reason, c and d are not possible functions for this graph, at least. And between a and b, the remaining two, we have x squared plus 9 and x squared minus 9. Well, x squared minus 9 would give us zeros of positive and -3, but positive and -3 are not roots on the graph. So for that reason, we're going to eliminate b. The remaining answer A is correct, and we can confirm that x squared plus 9 would produce two imaginary zeros. Because they're imaginary zeros, that means they're not roots on the graph. So A for sure. Okay, this example, we have 3 roots on our polynomial graph. So we're looking for 3 roots over here. One of our roots is -1. And so I'm looking for x plus 1 as a factor. So B and C. And for that reason, A and D don't have x plus 1. So for that reason, we're going to omit A and B as possible answers. And between B and C, C is the better answer. And the reason is because if I look at my graph, my roots are some number between -4 and -5, as well as some number between 4 and 5. And so if I think about square rooting the 19 and square rooting the 13 when I solve for x, the square root of 16 is right in between those two. Square root of 16 is 4. And so the square root of 13 would be less than 4. And the square root of 19 would be more than 4. And so I want to look for something that's more than 4 and less than -4. So for that reason, on our graph, that's what we have here. For that reason, 19 is going to be the better option. If that doesn't make total sense, try square rooting 13. You'll see it's less than 4. And so that's clearly not going to be a good option, which leaves the only option C. Okay, so for this one, our graph is a little little cattywampus on us, but if we say the roots here are -4, -1, and +4, then I'm looking for x plus 1 as one of my roots. So either a or b, have x plus 1. And then because of the x squared minus 16, that would produce roots of positive and -4. So B would be the correct answer for this one. All right, takeaways. So when we're looking at polynomial functions and we're trying to find roots, or when we come across a imaginary zero, we know this it means it's not going to produce a root on the graph. And then also we've seen some irrationals, and that just means that we kind of have to estimate our roots a little bit on our graph.